This video is about how to sketch the graph of a given function. 7a. Consider the function this. Find the f of -2. Basically, we just need to plug in. We substitute x by -2. So we have 3/4 -2 fourth power minus -2 third power minus 9 -2 squared plus 20. When you put into graphing calculator, make sure you put the parentheses. Then you will get 4. If you want to get the full marks, this substitution you have to show on your paper. Let's go to 7b. Find the derivative of f of x. On the booklet formula, this is given. So you got to use this formula to figure out the derivative. That equals 3/4 x to the fourth power minus x third power to the derivative minus 9x squared we do derivative plus 20 we do derivative. So you get 3/4 times 4x to the third power. For the coefficient stay minus 3x squared minus this 9 stay, then times 2x, then plus 0 for derivative of a constant number. We organize, you will get the 3x third power minus 3x squared minus 18x. Now let's go to 7c. The graph of a function f of x has a local minimum at the point where x equals -2. Using your answer to part B, show that there is a second local minimum at x equals 3. You have to use your answer to part B, which means the derivative function. We know if there is a local minimum at x equals 3, then the derivative of f of 3 should be equal to 0. So we check whether f prime of 3 equals 0 or not. So we get 3 times 3 to the third power minus 3 times 3 squared minus 18 times 3. You put into a graphing calculator, you will get 0. But how you show this is a local minimum, not a local maximum? You have to use this part B. Think about the graph. It will be like this. This point is x equals to 3. In other words, for x less than 3, this derivative will be less than 0 because the slope of a tangent line is negative. On the right side of this 3, the derivative of a function will be greater than 0. So you need to find a point on the left side of this 3 and also on the right side of this 3 to satisfy this and this. That's the way to show x equals to 3 is a minimum point. So the second step, you will plug in any number less than 3. We always choose a number close to this 3, so we use 2.99. And for on the right side, the x, I use 3.01. So we got the f prime of 2.99 equals 3 times 2.99 third power minus 3 times 2.99 squared. Then minus 18 times 2.99. We put into graphing calculator, you will get negative 0.447603, which means it's less than 0. Then we plug in 3.01 to this derivative function. You will get 3 times 3.01 third power minus 3 times 3.01 squared minus 18 times 3.01. You will get 0.452403. This is greater than 0. So at x equals 3, there is a second local minimum point. When you say show that, normally you rewrite the conclusion. So remember how you show at one point there is a local maximum or local minimum. This is 2 steps to show. Now let's go to 7D. The graph of the function f of x has a local minimum at the point where x equals negative 2. Sketch the graph of the function. F of x will be x between negative 5 to 5, and y is between negative 40 to 50. Indicate on your sketch the coordinates of y-intercept. First of all, you will put this function into y1. Then set up the window as a given. Then you will figure out 2 zeros and y-intercept, and then those 2 minimum point. When you set up the window for the scale, for the graphing calculator, you can just divide it by 10. But when you sketch the graph, make it bigger so that you don't have to draw too many labels. Let's do over here. This will be the x. If possible, use a ruler. This is a 0. Then we label as here's 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. This is a 20, 40. This will be 50. Here you will get the negative 20, negative 40. And we need to plot those points. This is a y-intercept. X-intercept will be 1.5. So it will be here. Then 3.94. It will be here. Just estimate. Then for the minimum point, it will be negative 2, 4. Negative 2, 4. The other minimum point is a 3, negative 27.25. Half of this will be 30. Estimate will be here. Then you connect these key points smoothly. That's it. Always remember how you can get the full marks for sketching the graph. 1 mark for axis labels and indicated scales. 1 mark for smooth curve with a correct general shape. 1 mark for all x and y intercepts. Last mark for correct local minimum and maximum points. Let's go to 7e. The graph of the function f of x has a local minimum at the point where x equals -2. Write down the coordinates of the local minimum. That is -2, 4. 7f, let t be the tangent to the graph of the function f of x at point 2, -12. Find the gradient of t, which means the slope of a tangent line. Therefore, you need to figure out this. From graphing calculator, you can get the -24. So you will say the gradient of t is -24. Let's go to 7g. The line L passed through the point 2, -12 and is perpendicular to this t. L has equation this format. Find the gradient of L, the value of B, and the value of C. Since the line L is perpendicular to this t, we know the slope of this t equals -24. Therefore, the slope of L equals, we can use -1 divided by -24. You can get the 1/24. Or from here, you can do opposite, then reciprocal, so that you will get the 1/24, the same answer. Then, since this L passing through the point, we label as x1, y1. We got to use this formula, y minus y1 equals slope x minus x1. So that we have y minus -12 equals, slope will be 1/24. X minus 2. Negative will be a positive, so we have y plus 12 equals 1/24 x minus 2. Get rid of this 24 first by multiply by 24 both sides. We got to do distributive property here. 24y plus 288 equals x minus 2. Move everything to the left side. You will get 24y minus x plus 288 plus 2 equals to 0. Then we combine like terms to change this linear function into this form. Remember the x first, so we do the -x plus 24y plus 290 equals to 0. Check here, the x is a positive x, so we divide by -1 both sides, which means we just change the sign for every single term in this equation. X minus 24y minus 290 equals to 0. Then you compare these two equations. You will say B equals -24 and C equals -290.